Can you all see the slides?
Yes, sir.
Okay, so in the last class we were looking at some introductory stuff and then the evolutionary pathway, right, of cultivated rice, right? How the cultivated rice evolved, and we said that there are two cultivated species we have, right? One is Oryza sativa and then Oryza glaberrima, right? So the Oryza sativa is the Asian rice. It has two types, and then those two types are Indica and Japonica, right? Are there any questions on the last class? Yeah, there's one question you asked in the last class, so I will answer that at the end of the lecture, today's lecture. Okay, so we will move forward with the introductory stuff, right? I hope sometimes we are going to cover under this section of rice, right? So this kind of a general introduction, right? For the global status of rice production, right? So this data is from 2020 data, right? I collected from the statistics available with the Food and Agriculture organizations. So they collect data from different countries, and then they maintain a database regarding many stuff regarding agriculture, especially the crop production and animal production. Okay, so according to 2020, that's kind of recent data we have. The total harvested area in the world is around 164 million hectares, right? And then total production is around 757 million tons, right? So using these two informations, right, in the very first class, calculate the yield and productivity, right? So now we have the production information and then harvested area, right? So you can simply calculate, estimate the average yield. That is around 4.6 tons per hectare, right? So it's around 4,600 kilograms, right? If you convert it, right? So that is global average yield, right? When you average across all the countries that cultivate rice, right? This is the average yield, right? You will get around 4.6 tons per hectare, right? So this Sri Lanka also is right in the recent past, right before this policy change came into place, like banning of agrochemicals, we also getting very closer to this yield, right? Very closer to the global average, right? It was around like 4.5 tons per hectare, right? We were very close, and we were self-sufficient as well, right? In the recent past, before this policy change came, right? So if you look like global status, right? You know, there are a few important cereal crops we have, like maize, wheat, rice, barley, right? So when you put it in the order of production, right? So the rice comes to the third place, right? The first highly produced cereal is maize, right? Followed by wheat, right? And then rice, right? And then rice. So if you look the largest producers in the world, the first one is China, right? And then India, Indonesia, Bangladesh, and Vietnam, right? So this is also based on the 2020 statistics, right? So you may remember that, right? If you trace back to the origin of rice, right? We said that it's somewhere in China, right? So China is the largest producer, and then they also have the largest land mass, right? When you compare, right, with other countries, and then India, Indonesia, and Bangladesh. Bangladesh also has a lot of rice production areas. If you see the country statistics, and then Vietnam, right? So those are the countries leads in producing rice. Okay. So let's come to our situation, right? What kind of production trend we have in Sri Lanka, right? So I have taken this figure from a published work, right? So let's try to understand this one. So here you see there are two axes, right? In the y-axis, so there are two, right? So you have the cultivated area in 1,000 hectares, right? So the primary y-axis you have the cultivated area, right? So that represents this blue line, right? Blue line. And then the secondary axis of the Y, we have the yield. The unit is in kilogram per hectare, right? Unit is in kilogram per hectare. That is indicated by this orange line, right? Orange line. So let's look at the cultivated area. What happened? So this in the x-axis we have the years, right? That is from around 1970s to closer to 2020, right? 2020. Right, you see the cultivated extent, right? Cultivated extent also increasing, but there are internal variations, right? What we mean by internal variations is that annually that could vary due to several reasons, right? Due to the climate factors or maybe input availability policy changes, right? That could impact this internal variation. But overall, you see an increasing trend, right? An increasing trend, right? So let me take this pen. So if you draw a line like this, like it goes like that, right? So overall, there's increasing trend in the cultivated area and also in the yield. So that indicates the productivity, right? Productivity in kilogram per hectare, right? Earlier it was right in 1970s. You see this one, right? Somewhere around in between 2,500 and 3,000, right? Now we have like somewhere closer to 4,500, right? So in the introductory, when I introduce the topics we will be covering, I said that there's a improvement occurred in improving this crop, right, through genetic interventions and other procedures, right? So because of that, right, the yield, we were able to increase the yield, right, of rice, right, through those interventions. So how that improvements happen, we will study, right, in the coming lectures. We will study that, right. So that's kind of a success story, right? And then in the very recent past, because of these policy changes, a lot of things has happened, but right before that we were also self-sufficient, right? Right um, after around 2010, right? We achieved that, right? Okay. So, are there any questions so far? Students?
Yes.
Okay. So you have to take down notes, right? When I explain this stuff, right? There's no bullet points, right? Then you have to take down notes, whatever I explain regarding this one. Okay. So then another important thing we should know is that this graph will show you, right? There are again here in the x-axis we have the years, right? From 1970s to around 2010, right? 2010. So in the primary y-axis, you have this fertilizer use in 1,000 metric tons, right? So that means, like, for example, if you want to read this 100, so you have to multiply by 1,000, right? So that indicates the value here. So let me take that 10. So it's 100, right? If it is 100, you have to read as 100,000 metric tons, okay? Because you have to multiply this by 1,000. So that's what it indicates, okay? Okay, so again in this one, right, in the secondary y-axis, we have the paddy production, right? Paddy production, that's also again 1,000 metric tons. For example, if you want to read this one, you have to read it as 500,000 metric tons, okay? So there are two lines, right? One is in a kind of a purple color that indicates the fertilizer use, right? Fertilizer use. So that means, like, it's a total fertilizer use, right? You may know that for rice we recommend, right, mostly the nitrogen, phosphorus, and potassium fertilizers, right? Those are the macronutrients, right? Macronutrients. So these fertilizer use account for all the fertilizers, right? All the fertilizers, and then the paddy production, right? That is in the dark blue line, right? Dark blue line that shows the paddy production. Okay. So you also see here, right, from 1970s, right? 70s. Okay, right. We said that the production has increased, right? Because we want to achieve self-sufficiency, right? Through a lot of improvement, the paddy production, that's the dark blue line. You see there's a increasing trend, right? Increasing trend. And also you see, right, the similar trend in the fertilizer usage, right? In the fertilizer usage, right? So when we improve the crop, right? When we improve the crop targeting high yields, right? We also wanted to provide required inputs, right? So that's what it indicates, right? So this improvement, right, in the production of paddy, right, or rice, right, occurred through genetic improvement, and also there was a continuous supply of inputs such as fertilizers were required, right, required. So that's why, right, there was a total failure when you ban this fertilizer. Our production of rice suddenly fall down, right? So that's a clear indication that shows you, right? So this improvement has occurred not only through genetics interventions but also through the required input supply, right? And also you may heard that, right? In the past we had fertilizer subsidy programs, right? Targeting paddy farmers. There are different opinions about that one, right? But anyway, um, for this success, right? For this success, the fertilizer supply also was helping, right? Was to some extent it was helping, right, to achieve higher rice production, right? That we will discuss in the coming lectures as well, right? Is that clear to you, right? Any questions regarding this one? To respond, otherwise I don't know whether you received it or not.
No, sir.
So can you understand, right, the increasing trend in both in parent production and the fertilizer usage in our country? Can you distinguish these things?
Yes, sir.
Okay. All right. So those are kind of statistics we have for rice production. That's an important crop for us, right? Then let us move to uh, the cropping intensity of rice, right? In Sri Lanka, right? You know that in the first year first semester course, that's the principles of crop production, right? You may have studied that, right? There are two seasons, two major rainy seasons we have in Sri Lanka, right? The first one is Maha, right? So that's along with this northeast monsoon, right? And then the Jala season, right? This is the period May to September roughly, right? So that's because of this southwest monsoon, right? So two major rainy seasons we have, and then the rice production season also aligned with that, right? Because rice require a lot of water, right? A lot of water, right? Because of that, we have to align the production, especially with seasons, especially when we cultivate it as a rainfed crop, right? Okay. So when you talk about intensity, right, cropping intensity, if you, for example, take 1 hectare of land, right, 1 hectare of land, and then if you cultivate this 1 hectare land for one season, right, in 1 year, right, within 1 year, if you cultivate it for one season, so that intensity we call it as 100%, right, 100% intensity. But think about rice, right? Think about rice. In majority of the areas, we are able to cultivate this rice, right? When we have supplementary irrigation, right? The two seasons within 1 year, right? So it's kind of so. What kind of intensity you can have for this one? So if you 1 hectare land, if you can cultivate for two seasons, right? So it's simple math, right? So here we say it's 100%. So you put this is 100 into 2, right? Is it clear to you? Students?
Sir, can you tell it again, sir?
Yeah, so we say that one season, right? Take a crop, right? Let me delete this one. So one season, right? So you cultivate one, so 1 hectare land. So we say that this is intensity. But say if it is two seasons, you can cultivate. Is that okay to you now?
Okay, sir.
Okay. So that's kind of idea you have to have, and then globally, right? There are classification, right? for rice growing environment or rice growing ecosystems, right? So differences there, right? Especially in this classification based on the water regimes, right? You know that the water is the major input for rice production, right? Or paddy production. So based on the water regimes, right, we can classify their rice growing environment or rice growing ecosystems, right? So in this figure that shows that classification, right? So it ranging from right if you see the left side, right, you have the upland, right, upland, and then in the right side we have the flood prone areas, right. So based on along this way, right, it goes towards right from the high elevation to the low elevation, right. Maybe closer to the coastal areas or maybe closer to the wetlands, right. That's how your landscape is located, right? So it may be so. So this is very low elevation area, right? This is the high elevation, right? So according to the water regime, right? Especially in the high elevation, you will have deficit for water, right? Deficit for water, but in the low elevation, there's a high chance that you will have the surplus water. Surplus means more than required, right? What is more than required? So you may have the surplus water, right? Based on that, right? We have um, basically we can find four systems, right? Four rice growing ecosystems. The first one is the upland rice, right? And then we have the rain-fed lowland, right? Rain-fed lowland. So the rain-fed lowland is the depending on the rainfall, right? The cultivation based on the rainfall, right? And then in between these two type of rain-fed lowland, right? We'll have the irrigated system, right? If the irrigation is available, right? We will have the irrigated rice, right? But according to this slope, right? If I go back to this rain-fed lowland, right? So if that rain-fed lowland is a little bit in the high elevation, right? There's high chance for that rain-fed lowland to be prone to the drought, right? Drought stresses, because we said it's a rain-fed cultivation, so the water availability depends on the rainfall, right? So since this is in a little bit high elevation, the water stagnation, right? The chance for the stagnation of water will be less. So then this cultivation may be prone to drought, right? But if you come to this rain-fed lowland in the low elevation, right? Of course, there can be chances for drought, but right, since this is closer to this maybe the coastal areas or maybe the wetlands, right? There will be high chance for this submergence, right? Submergence means the problems due to flood, right? Problems due to flood. So that rain-fed lowland cultivation can be prone to flood problems, right? And then obviously you have the last production system, that's a flood-prone system, right? That's closer to the wetlands or maybe to the coastal areas, right? So we will try to understand this how the rice systems varies, right? At least some major differences in this system, okay? So if you go to the upland rice, right? Upland rice, right? When I teach you the evolution, right? I said that the rice, the wild types of rice, they were upland plants, right? They evolved, rice evolved as upland crop, right? But we converted that crop to a lowland crop, right? Okay, so in the upland rice, right, the elevation, so we are talking about the landscape here, right? That's level to steeply sloping fields, right? You can see here, right? There's a steep slope, right? Or maybe it can be level land also, right? So that's the prominent landscape of this upland rice cultivated areas, rarely flooded, right? Why? Because it's in the high elevation, right? And also, we have to, we should know about this, whether the soil is aerobic or anaerobic, right? So I will try to explain this one, what we mean by aerobic and anaerobic, right? You should know this, especially for rice, right? Um, so take soil, right? Take soil, right? It has few components, right? If you think about soil, right, it has a mineral component, right? So that's an inorganic portion, right? Inorganic portion, and then it has an organic component, right? And then it has water, right? Soil water, and it has air, right? So this air, right, and water, right? You may have studied this in soil science, right? The basic soil science process, right? So this air and water makes around 50%, right? So they interchange their percentages and accounts for around 50% in the soil, right? In the normal soil, right? So when the soil is flooded, right? Flooded, right? Under flooded conditions, there be not any air, right? This component will be goes away, right? The water will capture all these spaces, right? All these spaces, right? Right. Under such conditions, we call, right, when this 50% only occupied by the water, there's very limited air, then we call it as an anaerobic soil, right? Right. So if the air is there, that's aerobic, right? If air is there for certain percentage, that's aerobic soil, right? So can you understand that difference between aerobic and anaerobic soils?
Yes, sir.
Okay. Okay, so since this upland rice is in the high elevation, it's not flooded, it's not under flooded conditions, so the soil is aerobic, right? Soil is aerobic, so that means there will be there in soil, right? Substantial percentage of air will be there in soil, right? And then rice in the system, right? Rice in the system is directly seeded on plowed dry soil, right? Or dibbled in wet non-puddle soil. Dibbled means like you make a hole and then you can just plant, right? Using planters, right? Planting equipment, you can use that, right? Because it's not a flooded condition, right? We are talking about upland rice system, right? So it's mostly flooded, planted in the dry soil, right? In the dry soil, or maybe you can make a hole when it's a little bit wet, right? But non-puddle, right? Right? Non-puddle soil. All right. So that's about upland rice, but we in Sri Lanka, right, we don't have much of this system, right? Because of this increasing water problems, right? Now there's an increasing attention towards this upland rice, producing rice in the uplands, because you can minimize the water, right? In this system, we will use less water when you compare with the other systems, right? But in Sri Lanka, this system is very rare, right? Very rare. Okay, so the second one is that the rain-fed lowland, right? If you go for this schematic diagram, right, this can be here in between, maybe in the little bit high elevation or maybe in the little bit low elevation, right? interruption. Hello, students. Can you see the slide?
Yes, sir.
Okay. Okay, so if you move to this rain-fed lowland, right? So this you can see level to slightly sloping, right? Because in this lowland rice cultivation, you have to maintain the water level, right? So if it is steep slope, right, like upland, you cannot store water, right? So that's the obvious issue we'll have, right? If it is slope like this one, right, you cannot store water, right? So more or less flat, right? Here, the system you can see, right? So that's why it's level to slightly sloping. We'll have banded fields, right? We'll have bunds, right? In the system, and then but in the rain-fed lowland, since this is rain-fed, rain-fed means the water availability decided by the rainfall, right? So there will be no continuous flooding, right? Of variable depth and duration of water, right? And then submergence will not exceed like 50 centimeter, right? So it's around 0.5 meter, right? You can imagine, right? That means submergence means the flood level, right? The water level you have in the field, right? So that will not exceed around more than 50 centimeter for more than 10 consecutive days, right? Such system we categorize under this ecosystem. Okay. So in this system, right, rice is transplanted or direct seeded in the puddle soil. Okay? So we have the available water for puddle, right, compared to the upland rice, right. So and then can be direct seeded in the plowed rice soil as well, right. If you want to start the cultivation before rain comes, right, then you can direct seed it in the plowed rice soil as well, right. And alternating between the aerobic and anaerobic soil, because as the water availability determined by the rainfall, right, when the flooded condition, when you have a water level, right, above the soil, right, that's the submergence we call in terms of rice cultivation, right. The soil will be anaerobic, right. When there's no water, right, or the level is low, then you will have the aerobic conditions, right. So under this system, depending on the rainfall, the aerobic or anaerobic nature of the soil will shift, right, between these two types. Okay, so that's rain-fed lowland, and then irrigated rice, right? So whenever we have the facilities to supplement water to the cultivation, right? So that's where this irrigated rice system comes, right? Again, level bonded fields with there should be, since we have control over water levels, right? There should be structures to control the water input and out, right? So into the field. So that's why we say about water control, right? Because under the rain-fed system, we are out of control, right? We don't have control over that. But under the irrigated system, we have control over supplying the water, right, to the field. And then rice transplanted or direct seeded in the puddle soil, right? Again, you have water, so you can do puddling, right? And then you can transplant or direct seed. And shallow flooded with anaerobic soil, right? If you continue to maintain the water level, right, then you will keep the soil anaerobic, right, under the anaerobic conditions, right? So, but in the rain-fed rice, you will sit, right, between aerobic and anaerobic conditions. So the last one is the flood prone, right? We hope we have 2 minutes more, right? So we'll cover the last one only. And then flood prone rice, right? Or it's called as the cultivation and in the tidal wetlands, right? So this level to slightly sloping fields, right? So it's kind of always underwater situation because it's in the very low elevation, right? Very low elevation near to the coastal areas or maybe closer to the wetlands, right? So here you have submergence that sorry, here, this one, right? So more than 10 consecutive days of medium to very deep flooding, right? Sometimes flood can reach up to 3 meters as well, right? The level of water, right? Depending on the flood risk, right? You have in that area, right? It can go up to 3 meters as well, right? So rice transplanted in further soil and they exceeded on plowed dry soil, and then aerobic or anaerobic soil depending on the water availability, right? Because here here also you don't have control, right, over the submergence level, right? And then the problem, other than the flood risk, right, in this ecosystem, the major problem we have the flood risk, right? Flood risk, and then there can be other problems like salinity, because I said this is the low elevation, so there can be fields that is closer to the coastal areas. So then the seawater can intrusion, right? Seawater intrusion can happen, right? Because of that, salinity problems can arise, or maybe several toxicities, right? Toxicity problems like iron toxicity and other toxicities, right? Can be problematic for this system. And then if it is closer to wetlands, right? The closer to wetlands, we will have the kind of different soils called peat soils, right? They are high in organic matter content, right? Sometimes you may get good productivity for that cultivation, but there can be different problems, right? Um, that may harbor some toxic elements, or maybe that affects the nutrient availability for the crop, right? There can be issues, right? So the most popular systems, right, are like the rain-fed lowland, this one, right, and then the irrigated rice. So those are the two systems very popular in Sri Lanka, right? We also have some system around here, right, but less with upland rice, right? Less with upland rice. So since we don't have time for discuss that question, so I will discuss the question you asked in the last week in the next class, right? And then, are there any questions before I end this part? So today we have covered like some production statistics globally regarding rice, and then also in Sri Lanka, and then we also studied what are the rice growing ecosystems, how they classified based on the water regimes, right? I hope that you will be clear about this. Any questions?